Hello students, welcome to All Force e-learning channel. This is K. Nageshwara, your physics faculty. Today we will deal with the session number 49, motion in a plane chapter, first year Neet. Okay, in the previous session we have dealt with the oblique projectile. We have derived one equation, isn't it? Let us see what we can do today in this session. Oblique projectile. I'm taking a xy coordinate system. So let us say from the origin a body is projected with an initial velocity u at an angle theta with the horizontal. So what happens, we have already seen in the previous session, the body follows a path something like this, a parabolic path, isn't it? And this u can be resolved into two components, ux and uy. This ux is expressed as u cos theta, uy is expressed as u sin theta, and this u vector, initial velocity of projection, u bar can be written as u cos theta I cap plus u sin theta j cap. This is what we have seen in the previous session. And we have also derived one equation something like this. Y is equal to tan theta x minus g by 2u square cos square theta into x square. Or in a simpler manner, it is expressed as ax minus bx square, isn't it? So we have seen this equation in the previous session. Okay, so this is what equation indicates that the body has followed a parabolic path. The trajectory of an oblique projectile is a parabola. So that's indicated by this equation. Y is equal to ax minus bx square. So you have to remember what this a is. A is tan theta. B is g by 2u square cos square theta. This knowledge of a and b also helps us to solve few problems. Okay. So now let us see this oblique projectile again. Here, what I'm going to talk about is in this picture, when the body is projected from this point, finally it is meeting somewhere here, isn't it? So when it is meeting at various points of its trajectory, how acceleration experienced by the body, velocity experienced by the body along horizontal direction and vertical direction, how those things are going to change. Let us just monitor those things. I have picked up these points, these black dots. These are the points that I have picked up on the trajectory, and I'm going to monitor the directions of horizontal component, vertical component, and acceleration experienced by the body at all these positions. Okay, 1, 2, 3, 4, 5. Okay, I'll start with the acceleration due to gravity. Acceleration due to gravity is z, isn't it? And the other one is horizontal component of velocity. I'm denoting this with vx, v subscript x, and the other one is vertical component of velocity vy. So let us see how this acceleration due to gravity experienced by the object at all these positions will change. See, this is how acceleration due to gravity exists at all these points. If you observe carefully, at all these points it is vertically in the downward direction. It doesn't matter whether the body is going upwards or it is coming downwards. At all these positions, it is experiencing acceleration which is equal to acceleration due to gravity, and its direction is always vertically in the downward direction. The other one, horizontal component of velocity, which is Vx. Let us see how it is going to change. See, horizontal component of velocity. At all these points, it is, in the horizontal direction only. There is no any change of the direction in case of what horizontal component of velocity. This point, I have stressed in the previous session also. Horizontal component of velocity, since it is perpendicular to acceleration due to gravity, it is not going to be influenced. It is not going to change throughout the journey of this body along this parabolic path. So here if it is ux which is equal to u cos theta, here also it is equal to ux only, here also it is equal to ux only, here also it is ux, and finally when it is striking at the ground at this point, there also horizontal component remains ux which is equal to u cos theta. What about vertical component of velocity? Yeah, initially this is the vertical component of velocity uy. After some time t, vertical component of velocity is vy, like this. By the time it has reached the maximum height, this point corresponds to it is corresponding to maximum height. Here the vertical component of velocity is 0. We all know that if a body is projected with initial velocity uy, for example, in the vertically upward direction, the maximum height, what happens to the final velocity? Final velocity becomes 0, and that maximum height is expressed as u square by 2g. We have already seen in motion in a straight line chapter, that to motion under gravity topic, we have seen that one, right? So here the vertical component, which is completely controlled by the force of gravity, what happens as it travels from this point to this point, it decreases, and finally by the time it reaches the peak, the maximum height, vy becomes 0, but horizontal component of velocity is still intact. It doesn't change, it remains constant. So if at all, if anybody asks you what is the total velocity of the body at the highest point of the trajectory of a oblique projectile, The total velocity will be equal to horizontal component of velocity, which is equal to u cos theta. Okay, so this is how vertical component changes. What about resultant velocity? See here, resultant velocity, initially it was u along this direction, making an angle theta with the horizontal. By the time it has reached here, what has happened? See, velocity has changed because ux is constant only, but vy is changing. No, so if vy is changing, the resultant of vy and ux will be different from this value u. And here the angle made by this v with the horizontal, this angle is also different from this theta. What happens to that angle? Actually, it decreases. By the time it goes here, the angle between resultant velocity and horizontal is 0 at the highest point, at the maximum height position, isn't it? And here, the resultant velocity and horizontal component of velocity both are along the same direction. That's because there is no any vertical component. Whatever velocity the body possesses, that is only horizontal component of velocity, and that is what the resultant velocity. Okay, so by the time it comes here, see what has happened to the vertical component of velocity? Its direction is reversed. It is in the downward direction. Before the point has reached this particular position, the vertical component of velocity is always in the upward direction. Okay, after crossing this maximum height, the vertical component its direction has been reversed and it is always in the downward direction. Okay, sometimes you can expect questions like what is the angle between vertical component of velocity and acceleration due to gravity during ascent in the sense, like if it is traveling from this point of projection to maximum height, then we call it as ascent, isn't it? When during ascent, what will be the angle between vertical component of velocity and acceleration due to gravity? As you see here, it's 180 degree, isn't it? But here, after crossing this maximum height point, the angle between vertical component of velocity vy and acceleration due to gravity g, it's 0, isn't it? It's 0. And here at this point, the angle between resultant velocity, what is this u, and acceleration due to gravity, how much is that? 90 plus theta. So angle between acceleration due to gravity and velocity of projection at the point of projection is how much? 90 plus theta. And here the resultant velocity is this one, ux. Acceleration due to gravity is g in the downward direction. What is the angle between acceleration due to gravity and resultant velocity? 90. Okay, and here again, see, if it is projected with an velocity u, it is going to strike the ground also with a velocity u. There is a symmetry. Okay, similarly, the component of vy, whatever vy is there, that is also going to be exactly equal to uy. Whatever initially vertically upward component is there, finally also it will be same. It means the angle, initially it was making an angle theta with the horizontal. So finally also how much angle it is going to make with the horizontal? It is going to make an angle theta. So this is a kind of symmetry that exists, in the oblique projectile motion. Okay, at the point of projection, at the point where it strikes the ground. Okay, similar picture will reflect except vertical component of velocity's direction is reversed. That's it. Okay, so these are a few basics connected with oblique projectile motion. Now let us talk about time of flight. Time of flight in the sense, time taken by the body to finish the complete journey. Okay, so what I'm going to talk about, if body is projected from this point, whatever time it takes to travel up to this point, that time is called as time of flight. Let us try to find out that time of flight. Before I calculate time of flight, I'll find out the time of ascent. Okay, time of ascent in the sense, time taken by the body to reach maximum height. At maximum, if we wanted to find out height, means vertical distance covered by the body, what you are going to make use? You are going to make use this vy, vertical component of velocity. See, after a time t, vertical component of velocity vy is expressed as vy is equal to uy plus a by t. Since it is upward motion, this ay will be replaced with minus g, isn't it? And uy is what? U sin theta. So it is replaced here. So vy is equal to u sin theta minus gt, isn't it? And what is going to happen to this vertical component of velocity by the time it reaches maximum height? This vy becomes 0. Just now we have seen. So if you replace this vy with 0, what you will have? At the maximum height, vy is 0. What you will have? U sin theta minus gt is equal to 0. Okay. So at that time, whatever t is there in the equation, that t is what? Time of ascent. Time taken by the body to reach maximum height. So this is the time of ascent. Whatever t is here, that is time of ascent. That can be written as, u sin theta by g. From this equation, we can write it like this. So time of ascent, time taken by the body to reach maximum height is equal to u sin theta by g, isn't it? Now, in this case, whatever time it takes to reach maximum height, that will be exactly equal to time of descent. We have already seen in motion in a straight line chapter also. In vertical motion, whatever time the body takes, provided air resistance is ignored, whatever time it takes for ascent, same time will be taken by the body to come down, isn't it? Okay, so both are equal. So here, time of ascent we have already we have found already u sin theta by g. It means that u sin theta by g is also equal to time of descent. And now what will be the time of flight? Total time of flight. Time of ascent plus time of descent. Ta plus Tb. U sin theta by g plus u sin theta by g, which is equal to 2u sin theta by g. So our conclusion is total time of flight, capital T, is equal to 2u sin theta by g. So that's how you can find time of flight. And this equation is very, very important. Time of flight, time taken for the total journey, starting from this point to this point. How much is that? 2u sin theta by g. All these details, you should possess on your fingertips. Very quickly you should be able to access. These are fundamental details connected with the oblique projectile. Time of flight is equal to 2u sin theta by g. Time of ascent, time of descent, both are equal. U sin theta by g. Okay, right. So now horizontal range and maximum height. Let us talk about this one. Horizontal range. See, horizontal range in the sense, when a body is projected at an angle theta with an initial velocity u, whatever horizontal distance it covers, that is called as horizontal range. So this time taken for this, time taken by the body to cover this horizontal distance is how much? Equal to time of flight only, isn't it? Whatever time it takes to travel along this trajectory up to this point, during that time, horizontally, how much a distance it is covering? A distance equal to capital R, which is called as horizontal range. And with what velocity the body covers this horizontal distance? It covers with a velocity equal to u cos theta. This u cos theta, throughout the journey, it remains constant. Just now we have seen. So that is what the velocity which is taking the body along horizontal direction and which is constant. Okay, now velocity which is which is responsible for horizontal range is known to us. Time of flight is also known to us. Can't we find horizontal range? So distance is equal to what, or displacement is equal to velocity into time, isn't it? So range is equal to what? R is equal to, what is the horizontal component of velocity? Ux into time of flight. Ux is known to us, u cos theta. T is also known to us, in fact, u cos theta into T is what? Just now we have seen 2u sin theta by g. Students, you have to remember these details. These are very, very important. So capital T, time of flight is equal to 2u sin theta by g. Now let us simplify this. What you will get? U square, what you will get? 2u square sin theta cos theta by g. But 2 sin theta cos theta can be replaced with sin 2 theta. Then finally, what is our conclusion? U into u square, and whatever cos into 2 into sin theta is that can be replaced with the sin 2 theta. Okay, in the denominator you have g. So this is the expression for horizontal range, and this is very, very important. Horizontal range is equal to what? U square sin 2 theta by g. Okay, time of flight is equal to how much? 2u sin theta by g. Okay, right. Let us proceed with maximum height. So this is what maximum height is, isn't it? So in how much time the body reaches to this maximum height in a time equal to what? U, we have seen, right, in the previous case. What is that? This is what the time of ascent is. In a time equal to u sin theta by g, the body reaches to the maximum height. Okay, so now let us say this one. If I know that if a body is projected with a velocity u, if I ask you about the maximum height reached by the body, what is your answer? It is u square by 2g. Now here, what is the velocity in the vertical upward direction? Initially u sin theta. So you can consider this situation as if a body is projected vertically in the upward direction with an initial velocity equal to u sin theta. Okay, so what will the maximum height reached? U square by what? 2g. In place of u, what you have to substitute? You have to substitute u sin theta. Let us see that. So h is equal to ui square by 2g, and this ui, it has to be replaced with what? U sin theta. So if it is replaced with u sin theta, what you will get? U square sin square theta by 2g. So our conclusion is maximum height reached by the body is u square sin square theta by 2g. Okay. Of course, we can write a relation between these two also. Okay. We can do that. Let us recollect all these things once. I'm telling you again, these details are very, very important. Let us go back once quickly. So this equation is important. y is equal to tan theta x minus g by 2u square cos square theta. Students, you have to remember this. Okay, you should know what A is, what B is. In the previous session, I have discussed few problems with you, and in those problems, y is equal to, in this format, expressions were given, and you were asked to find out what initial velocity of projection is. Okay, or what is the angle of projection. Such kind of details you are supposed to find out, right? So you should know what A is. If you know that A is equal to tan theta, you can find the angle. If you know that B is equal to g by 2u square cos square theta, you will have a chance to find out initial velocity. Okay, so this equation is important, and these details are also very important. Okay, at the maximum height, vertical component of velocity is 0, and throughout the journey, horizontal component remains constant, which is equal to ux everywhere. Okay, and the scenario at the point of projection, at the point where it strikes the ground, it will be almost similar, except the vertical components of velocities directions will be reversed. Rest everything remains same. G is in the downward direction, G is in the downward direction. Ux, here also ux. This is theta, and this angle is also theta. This is u, this is also u. Here uy is in the upward direction, but whereas here uy is in the downward direction. That's the only difference. Okay, and change in momentum, that is also important. Change in momentum in the sense final momentum minus initial momentum. So you know how to calculate momentum. Momentum is mass into velocity. With that you can calculate change in momentum. The next one, what we have seen, this one. Here, what is the conclusion? Time of ascent. Time of ascent, time of descent, both are same, which are equal to u sin theta by g. So time of flight is how much? 2u sin theta by g. Time taken by the body to complete this total parabolic path is how much? 2u sin theta by g. So, and horizontal range, u square sin 2 theta by g. R is equal to u square sin 2 theta by g. This formula, this seems to be very simple, and based on this formula, you can expect a few tricky problems. Okay, all that you should know is you have to understand this trajectory part completely. In the later sessions also, we'll be discussing about several other points, like what is the velocity, total velocity at this point, and the angle made by total velocity with the horizontal. All those details will be discussed, okay, in the later sessions. And what is the maximum height? Maximum height is equal to u square sin square theta by 2g. So these are a few important details, children. So with this, I will conclude the session, and in the next coming session, we'll proceed with a few problems and a few other details connected with the trajectory of oblique projectile. Thank you, students.